Welcome to this explainer. Look, if you're gearing up for your WAEC, JAMB, or NECO exams, you already know that mastering chemical formulas can be, well, a bit tricky. But don't worry, that's exactly why we're here. Today, with QandAHelp as our ultimate study companion, we're going to break down these complex ideas so you can walk right into that exam room with absolute, total confidence. Let's dive right in, shall we? Okay, so here's our mission for today. We're looking at WASSCE Chemistry 2026, question 5. It reads, if carbon forms CX₄ and CY₂ with elements X and Y respectively, the formula of the compound that would be formed between elements X and Y is A, X₂Y4, B, YX, C, XY₂, or D, X₂Y. You know, I actually love this kind of question because it's basically a giant chemistry puzzle. We get to play detective here to uncover the unknown valencies of elements X and Y. And once we find those hidden valencies, we can perfectly predict exactly how they're going to bond with each other.
So, to solve this puzzle, we absolutely have to start with the element that anchors the whole entire question, and that is carbon. And the magic number you need to remember here is 4. As you probably remember from class, carbon normally forms 4 bonds. It has a valency of 4. I always love to think of carbon as having exactly 4 hands that must hold on to other atoms. It literally cannot leave any of those hands empty, and nope, it doesn't have a secret 5th hand. It has specifically 4. So keep that 4 firmly locked in your mind.
Right, let's move to our first compound and see how this all builds. We're looking at CX₄. We've got one single carbon atom combining with 4 X atoms. Now remember those 4 carbon hands we just talked about? Well, since one carbon atom is using its 4 hands to hold 4 separate X atoms, all 4 of those bonding units are being shared out equally. So the total valency supplied by those X atoms combined must perfectly equal 4 to keep that carbon happy and satisfied. So think about it. If 4 X atoms are holding 4 hands, then each individual X atom has to be holding exactly 1. 4 divided by 4 is 1, right? Simple math. This means element X is monovalent. It has a valency of just 1. And boom, that is the first half of our code completely cracked. Okay, now let's move on to our second compound, which is CY₂. Now the carbon atom here is exactly the same. It still has its 4 hands, and they are constantly looking for a partner. But this time around, those 4 hands are being held by only 2 Y atoms. The total valency that those Y atoms need to supply to completely satisfy the carbon is still exactly 4. So if we're dividing those 4 carbon hands between just 2 Y atoms, that means each Y atom must be grabbing onto 2 hands. 4 divided by 2 equals 2. This tells us right away that each Y atom must contribute 2 bonding units. Therefore, element Y has a valency of 2. It's divalent. And just like that, our detective work on the original compounds is totally complete. We've found our 2 missing valencies. X is 1 and Y is 2.
Now it is time to put all this together using the good old criss-cross technique. Here's how we do it. Step 1. We write those valencies side by side, X with a 1 and Y with a 2. Step 2, we crisscross them. The valency of Y, which is 2, literally crosses over to become the subscript of X, and the valency of X, which is 1, crosses over to become the subscript of Y. That gives us X₂Y1. But hold on, look closely at step 3. In standard chemistry conventions, you know we never actually write a subscript of 1 in our formulas, right? It's always just implied. So we simply drop that 1, leaving us with our clean, final formula, X₂Y.
Now you might be wondering, why does this ratio work out so perfectly? Well, let's verify it just to be absolutely sure we're on the right track here. In our formula, X₂Y, we have 2 atoms of X. Since each X has a valency of 1, that gives us a grand total of 2 bonding units. We also have 1 single atom of Y, but since Y has a valency of 2, that also gives us 2 bonding units. See? They are completely equal. It's perfectly balanced. Think of it like a really simple analogy. 2 people carrying 1 grocery bag each perfectly balances out 1 strong person carrying 2 bags. It is just perfect equilibrium.
So let's systematically eliminate the wrong options from the exam by checking for that exact balance we just talked about. Look at option A, X₂Y4. X contributes 2, but Y contributes 8. Yeah, 2 definitely does not equal 8, so A is out. Option B is YX. Y contributes 2, X contributes 1. Completely unequal, so that's incorrect. Option C is XY₂. X gives 1, Y gives 4. Again, a total mismatch. Incorrect. But then we look at option D, X₂Y. X contributes 2, Y contributes 2. They match up perfectly. This confirms D is absolutely the only chemically sound and balanced answer.
Now, we all know exams are basically a race against the clock, so let's summarize a super fast shortcut for you to use next time. If carbon is the central atom with its known valency of 4 and you see 4 atoms attached to it, like in CX₄, immediately know that that element has a valency of 1, just instantly. If you see 2 atoms attached, like in CY₂, immediately know it has a valency of 2. Then, honestly, don't even overthink it. Just crisscross X1 and Y2 to get X₂Y. It literally takes less than 10 seconds once you spot that pattern on the page.
Let's pause for just a second. I really want to challenge you to lock in this new knowledge right now. Try applying that exact shortcut we just learned to this quick quiz. Ready? Carbon forms CM₄ and CN₂. Think about it for just a beat. What compound will elements M and N form together? Fantastic job if you spotted the pattern immediately. Here is the solution. CM₄ means M has a valency of 1. CN₂ means N has a valency of 2. You crisscross M1 and N2 exactly like before, and boom, you effortlessly get M2N. See how incredibly fast you can deduce those valencies once you know the secret? You're basically becoming a formula-writing machine at this point.
Okay, let's push it just a little bit further with one final quick quiz. What happens if neither element has a valency of 1? Let's see. Element P has a valency of 3. Element Q has a valency of 2. What's their compound formula going to be? Take a quick moment to work that out in your head.
And here is the sheer power of the criss-cross method. It works flawlessly every single time. You take P3 and Q2, you crisscross those numbers, and you immediately get P2, Q3. Let's do a really quick balance check just to be sure. 2 atoms of P times a valency of 3 gives us 6 bonding units. 3 atoms of Q times a valency of 2 also gives us 6 bonding units. 6 equals 6. It balances out perfectly, and you didn't even have to break a sweat. So, bringing it all back to our original WASSCE question, our correct answer is undeniably D, X₂Y. Massive congratulations on mastering valence transfer today. Honestly, being able to decode these unseen connections between atoms is exactly what separates a good chemistry student from a great one. You can practice way more of these types of questions and find in-depth breakdowns just like this one over at QandAHelp.com. And hey, make sure to subscribe so you never miss out on these exam strategies. I'm going to leave you with this final thought. If something as simple as the number of atoms attached to carbon can reveal the hidden architecture of entirely new compounds, what other chemical secrets are hiding in plain sight in your past papers just waiting for you to crisscross them? Keep exploring and keep learning.